Okay, good morning, students. You'll notice that inside the lesson package, the examples given does not tally with the ones inside your notes. Okay, so in this video, I'm going to demonstrate to you how to answer those questions inside your own notes. Okay, but you can also look through the examples that is given inside the video again to understand how to answer those questions as well. Okay, because the exams, okay, will most likely have all sorts of types of questions for you to try on. Okay, so I believe some of you noticed that the portion here, okay, on the formula, you're not very sure. Okay, so these are two formulas that was actually mentioned inside the question itself. Okay, first and foremost, okay, when we talk about energy transfer and we talk about current, okay, so let's highlight energy transfer. Energy transfer, we always label it as E. When we talk about current, it's always labeled as I. Okay, so for energy transferred when current flows through an appliance, we are looking at VIT, yeah, which is potential difference times the current flowing through the appliance multiplied by the time taken to continue to work the device. Okay, so this is the energy that is transferred. Yeah. Next is the electric power. Electric power, usually we will remember it as power equals to V times I. So one recommendations that I will recommend you, okay, is to remember this formula first. Power equals to V times I. Okay, as well as power is equals to energy divided by time. You notice that when we combine these two formulas, okay, you get this. Power is equals to VI. Substitute this formula over here, you get energy divided by time equals to VI, which will give you energy equals to VIT when the time is brought over to this side. Okay, cross multiply. Yeah, so with these two formulas, you can actually get this top formula again. Okay, now take note, SI unit for power is in watts, capital W for the symbol. Okay, let's look at the example given inside your notes. Okay, first and foremost, okay, can you please draw this diagram for yourself? Next, let's answer the question. Okay, as you read through, highlight the points or highlight the things that you already know and label it so that you don't get yourself confused. Okay, that's always our technique. Yeah, so let's read the question together. A flashlight bulb is connected to a 3.0 volt battery. Okay, so the moment you see 3.0 volt, what symbol do we use? Yes, very good. It should be capital V. The ammeter shows a reading of 0.70 amperes. What does this represent? Yes, it should be I. Next, what is the electrical power used by the bulb? Now, when they mention electrical power here, okay, we will straight away use the symbol P, capital P, to help us to take note that it's actually talking about power. Now look at the three symbols that you've written down. P, V, I. Which formula do you think you can use to solve this question? Very good, students. It should be P equals to V times I. Power equals to potential difference times the current flowing through it. But in this case, you notice there's no potential difference inside this circuit. Okay, but there's an EMF that is labeled by the 3.0 volts of the battery. But to take note, let's follow the battery. Okay, the wires that's connecting to the battery. Okay, you notice that as you move back to the light bulb, the wire is only connected to the light bulb. So which means that this 3.0 volts is actually the potential difference across the light bulb. Okay, let's substitute in the values, okay, and work out our solution. Okay, so power equals to V times I. Substitute accordingly. 3.0 multiplied by 0.70, which will give us a value of 2.1 watts. Okay, so this is the power that is required. Now always remember, inside the questions itself, our final answer is always 2 or 3 significant figures. So check, is this 2 significant figures or 3 significant figures? If it's not, please change accordingly. Next, let's look at the next question. Okay, in this case, in the previous case, 2.1 watts, here is 2 SF. Okay, let's look at the next question. Example 2. An electric iron has a heating element of resistance, underline resistance, 60 ohms. Okay, and it's connected to the 240 volts mains. Calculate the electric power produced in the heating element and the amount of electrical energy consumed when operating the iron for 20 minutes. Oh my, there's so many information available here. But do not worry, use the methods that we have already discussed during our lesson time. So let's go through the question again. An electric iron with a heating element of resistance 60 ohms. What do we usually denote the resistance of 60 ohms? What do we usually use as a symbol for resistance? Can you remember? Yes, it's supposed to be capital R. Okay, down here, 240 volts. What's the symbol that we usually use? Yes, it's capital V. Electrical power. What's the symbol that we use? Yes, it's capital P. The amount of electrical energy. Look at the word energy. What do we use? Yes, it's capital E. What about 20 minutes? Yes, it's time T. Now, let's look back at the question. Part A. How do we answer part A now? P is the power, which is what the question wants. But if you look at the question itself, it does not give you an I. So what do we do? Now, if you are worried about this, please don't. Let's look back at the formula that is given to you at the start of the lesson itself. Now you notice that these two are the formulas that is given, but take note, we always start from here. Power equals to V times I. Is there any other formulas that you are familiar with in electricity that we are always using? Yes, it's V equals to IR. Okay, so now we are going to derive one formula from here, P equals to VI, using this. In fact, we can derive quite a number of formulas. Okay, so this is how we do it. First, I'll make I the subject of the formula, which will give us V over R. Next, we will substitute into the formula for power itself. Since power equals to VI, it's the same as power equals to V times V over R. This will give us V squared over R. So this is our third formula. Power equals to V squared over R. So now we can use this formula. Why? Because we have the resistance here we have the potential difference here, and this is our power, which is what the question have in this side. Power, resistance, potential difference. So let's answer part A already. Since I know power equals to V squared over R, I can substitute accordingly. Okay, which will give us 240 square divided by 60 ohms. Okay, so when you work this out, you get a value of 960 watts. See? Very easy, right? Let's look at part B. Okay, for part B, you're required to find electrical energy that is consumed when operating the iron for 20 minutes. Now take note, for all our calculations, we will usually take time as seconds. There's only one exception, which we'll cover a little bit later. So let's look at the conversion first. Since we need to change 20 minutes into seconds, okay, we will get 1200 seconds. Why? Because 1 minute is 60 seconds, which will mean 20 times 60 will give us the value for the seconds for 20 minutes. Okay, now that we have time in seconds, let's look at the working again. Okay, remember from before, energy is equals to VIT. If you can't remember this one, at the very least, know how to derive your formula out from P equals to VI and P equals to E over T. So, like what we have seen just now, energy is VIT. Substitute accordingly. But you realize that if I use this formula, I will not be able to get the answer. Because what is VI? Inside this question, there is no V, there's no I. So what do we do? Now you notice that in the previous part here, power is equals to V times I. Okay, and power is equals to energy divided by time. Which will also mean that if you are smart enough, if this formula cannot work, we can always use power is equals to energy divided by time to get our answer. Where do we get the value for power? Aha! Look at part A. Value of power is over here. So, energy is equals to power times time. So I'll take the value from before, multiply by 1200. I'll get my value that is required by the question. 1152,000 joules. Oh my, do you think this is the final answer? Yes, very good. Some of you have noticed that this is not the final answer. Our final answer should be 2 or 3 significant figures. So I need to convert into 2 or 3 significant figures for this value. So it should be equals to 115,000 joules for 3 SF, or your answer should be 120,000 joules. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let's look at example 3. Please try the question on your own and pause this video now. Once you're ready, restart the video again and continue so that you can get the answer. Okay, let's look at the question. For those who are ready, please continue. For those who are not, continue to pause the video and try the question on your own. Please do not deprive yourself the opportunity to think. For those who are ready, let's go. A filament lamp rated as 60 watts. What does 60 watts represent here? Yes, it represents power. What does 240 volts represent here? Yes, it represents V. Okay, it's connected to a 240 volt power supply. Oh my, there is two volts, two different volts here. One is talking about the lamp, the other one is talking about the power supply. But if you read through the rest of the question, you realize that it doesn't really matter here. Okay, so let's just take this value, 240 volts. Okay, the current flowing through, find the current that is flowing through the lamp. Current. What symbol do we use for current? Yes, it's I. So if you look through P, V, I, part A, do you have the solution already? Okay, let's continue. Part A, power equals to V times I. So if I continue from here, I will substitute the values accordingly. 60 watts equals to 240 volts multiplied by I for us to find the current that is flowing through. So I'll get half if I'm not wrong. Let's double check the value. No, it's 1/4. So it's 0.25 amperes. So is this our final answer? Part B. You are required to find the resistance of the filament. Do we have a formula that can allow us to find the resistance straight away? Yes, we do. What is the formula? Power equals to V squared over R. If you remember this formula, you will be able to do it quite quickly. If not, you can always continue from here. Remember, there are multiple ways to get the same answer, especially for the topics on electricity. Okay, so let's use this value. I'm going to show you another method, okay, later on to help you to understand that there are multiple methods. Okay, so power equals to V squared over R. Okay, 60 is equals to 240 squared divided by R. Convert. Cross multiply. I'll get this, and I can work out the value to be 960 ohms. Yeah. Okay, so what's the second method? Second method actually requires you to use this value. Okay, so what formula do we use from there? V equals to IR. Okay, so V is 240 volts here, right? I, given in your previous part, is 0.25. Find R. You notice that the solution or the final answer will be the same. Okay, let's double check. Yes, it's the same. So you see, there are multiple ways to get the same answer. Okay, so you have to be very confident of what you're doing. Okay, I run out of space here. I'm going to do part C at the bottom here. Part C. Okay, let's look back at the question. The energy produced by the lamp when it's switched on for 8 hours. Take note, this is our time. I'm looking for the energy. So what do I need to do to find my solution? Yes, most of you will have noticed that power is just energy divided by time. Okay, and if I use this, I can actually get the solution quite quickly. So power is 60 watts multiplied by time, which is 8 hours. But take note of what I mentioned just now. Time should be in, yes, it should be in seconds. So please convert it into seconds. Okay, for those who have forgotten, 1 hour is actually 60 minutes. 1 minute is 60 seconds. So 1 hour is actually 3,600 seconds. Okay, please do the calculation. And you'll get this value, 1728000 joules. Now you notice that the value here is not 3 significant figures again, so please convert it, or please round it off to 3 significant figures or 2 significant figures. So you should get 1730000 joules for 3SF, or 1700000 joules for 2SF. Okay, so this is example 3. Okay, some of you have moved on to example 4 as well. I've also shown, or the previous videos also show it in part 3 of that lesson package. Okay, so for those who are over here already, well done. For those who are not, I would require you all to read through or listen through part 3 of the video before you move on to this stage. Okay, let's look at how to answer example 4. Okay, like I say again, if you have not seen part 3 of the previous video, please go back and see part 3 first. Once you are done, we will continue from here. Down here in this question, a 1.5 kW electrical heater. Okay, this one is supposed to be heater. Okay, now what is this 1.5 kW? For those who have remembered your chapter 1, K here means kilo. Very good. So 1.5 kilowatts electrical heater is used to heat a large container of water for 2 hours. Calculate the amount of electrical energy used by the heater in kilowatt hour, in joules. Now take note, this kWh means kilowatt hour. There is no new formula to work out this portion. So how do we get this formula out from the previous formula? Or what formula do we actually use? Okay, if you recap the previous part, you have this formula, E equals to VIT, which is also the same as power times time. Power here is kilowatts. Time is in hours. So my unit for energy would be kilowatt hours. Okay, so we only use time in hours if we want the energy to be in kilowatt hours, which also means that your power must be changed into kilowatts. Okay, so let's look back at the question. Calculate the amount of electrical energy used by the heater in part A, kilowatt hours. So energy is equals to power times time. Substitute the values accordingly. I have 1.5 kilowatts multiplied by time in hours, which is 2 here. You get 3.0 kilowatt hour. This is the answer that we need. Part B. You are required to find the answer for electrical energy in joules. What formula do we use? Yes, we still use the same formula. Energy is equals to power times time. So, power here is still the same, 1.5 kilowatts, but when you want the answer to be in joules, then your unit for power must be in terms of watts, which will mean I need to multiply by 1000 here. Time will be in seconds. Okay, you notice that this will give you a significantly bigger value than the kilowatt hours. Okay, it will give you this value 1080.1234 joules. Okay, why do we have two different units here then? Okay, basically in daily life we want to shorten the way that we write. We don't want to see so many zeros because it will confuse most people. So this is the preferred unit, kilowatt hours. Okay, but do take note of how to calculate in terms of joules as well. So let's go back to this one. Okay, please jot it down in your notes. If you want your energy to be in terms of joules, your power should be in terms of watts, and your time should be in terms of seconds. Okay, so there's two scenarios here. Okay, so let's look at example 5. Example 5 wants you to calculate the cost of electricity. So you need the knowledge from here to calculate the cost of electricity here. Okay, please go and try this question now. I hope that you have tried this question. Let's look through how to answer this question. If Singapore Power charges 18 cents for each kilowatt hour, take note of the units, kilowatt hour. So what does this mean? It means 1 kilowatt hour is 18 cents, costs 18 cents, okay? 1 kilowatt hour costs 18 cents. Okay, then after that, let's move on. Calculate the total cost of using a 3 kilowatt electrical kettle for 20 minutes and a 100 watt filament bulb for 5 hours. Oh my, now we got two different things. So what do? Do not worry. Okay, you will just need to calculate the amount of energy that is required for this in kilowatt hours for the kettle, amount of energy that is required for the filament bulb in kilowatt hours. Then after that, sum them up together and multiply by 18 cents to get the total cost. So let's look at it again. Okay, total cost of using a 3 kilowatt electrical kettle for 20 minutes. So let's find the energy required for the kettle. Please go and try now. For those who have tried it, well done. Check your answer with mine. It should be like this. Why do I have this? Remember, we need to change all the time, 20 minutes here, okay, into hours. Okay, so if you have done it correctly, you should get 1 kilowatt hour for the electric kettle. Okay, let's try the other one. Energy required for the filament lamp. Go and try it now. See whether you can get the same answer as mine. For those who have tried it, well done. Double check your value with mine. Okay, remember in this case, you need to change your power into kilowatts, and in order to do that, your 100 watts need to multiply by 1000. Okay, so if you've done it correctly, you should get this working and you get the following answer: 0.5 kilowatt hour. So total energy that is used by this family would be 0.5 kilowatt hour plus 1 kilowatt hour, which will give us 1.5 kilowatt hour. Okay, and at the end of it, we are looking at the cost, remember? So let's check the question again. Question is asking you to calculate the total cost, money. Okay, so how do I calculate the cost? So cost of electricity use is equals to the energy multiplied by the cost per kilowatt hour. So that would mean 1.5 kilowatt hour, the total energy that is used, multiplied by 18 cents. Okay, this will give us a total cost of $27. Sorry, 27 cents. Okay, students, please take note, do not change your cost from cents to dollars unnecessarily, as this will usually be the place where most of you will make mistakes. So I hope that these 4 videos helps you in understanding this first half of the chapter. We'll continue the rest of this chapter when you come back for our lessons. Okay, so if you're not sure, please view through the lesson again, the lesson package again, and hopefully you can answer or learn the knowledge better. Okay, so what are the formulas? In summary, what are the formulas that we are looking at? P equals to VI, E equals to VIT, and from this P equals to VI, we can actually come out with a few other formulas, one of it being P equals to V squared over R. Okay, so thank you very much, students. I'll see you when you come back.